Beyond the stars of our familiar night sky, far from the Earth we know, lies a distant world that has captured the imagination of scientists and dreamers alike. Proxima b, a planet orbiting the red dwarf star Proxima Centauri, is the closest known exoplanet to our solar system. Discovered in 2016, Proxima b holds a tantalizing possibility. Could this distant, alien world be our next home? As we reach out into the cosmos, this planet stands as a potential candidate for human colonization. But what would it take for us to survive there? Could we really live on Proxima b, a world so far away and so different from Earth? Proxima b orbits its star in what we call the habitable zone, an area where liquid water could potentially exist on the surface. For centuries, the search for life beyond Earth has been driven by this one question. Where might water, that vital element for life as we know it, be found elsewhere in the universe? Proxima b's placement in the habitable zone made it one of the most promising candidates in our quest for extraterrestrial life. But as we dig deeper into the planet's characteristics, we realize that while it holds promise, the conditions on Proxima b are far from ideal for human habitation. One of the first challenges we encounter is Proxima b's unique orbit. The planet is tidally locked to its star, meaning that one hemisphere always faces the star, while the other remains in eternal night. This creates a stark divide. The day side is likely unbearably hot, bathed in the unyielding glow of Proxima Centauri, while the night side is frozen in a permanent chill. This extreme contrast between light and dark would make Proxima be a difficult place for humans to survive. A world where one half is scorched and the other is locked in darkness is far from a familiar environment. Between these extremes lies the Terminator line, the boundary where day meets night. It is here, where the temperatures might be moderate, that the conditions might be more hospitable for life. But this zone is not without its own dangers. Powerful storms could rage across the Terminator, driven by the massive temperature difference between the two sides. Winds and turbulent weather would be constant, and in these harsh conditions, the survival of any form of life, especially human life, would be an enormous challenge. Building a stable habitat in such an environment would require cutting-edge technology and innovation. Surviving on Proxima b would demand resilience, technological ingenuity, and extreme adaptability. Colonists would need to rely on specially designed habitats, sealed environments that would protect them from the brutal temperature fluctuations, the solar radiation, and the fierce winds. These habitats would need to be self-sustaining, equipped with life support systems that could recycle air, water, and food. While the concept of terraforming, changing the planet's atmosphere to make it more Earth-like, might seem appealing, it's still far beyond our current technological capabilities. Instead, any attempt to colonize Proxima b would likely rely on creating artificial ecosystems within biodomes or underground cities. Another significant obstacle comes from Proxima Centauri itself. As a red dwarf star, Proxima Centauri is much smaller and cooler than our Sun, but it is far more active. Red dwarfs are notorious for their violent solar flares, which emit bursts of harmful radiation. This radiation poses a major threat to any life on Proxima b. Without a protective magnetic field, the planet's atmosphere might be vulnerable to being stripped away, leaving it uninhabitable. Even if the planet retains its atmosphere, constant bombardment by radiation could create a hostile environment for humans, forcing us to rely on advanced shielding and protective technologies just to survive. One of the most pressing questions is whether Proxima b even has the right conditions for life to thrive. While it's located in the habitable zone, scientists have yet to determine if its atmosphere is thick enough to support liquid water. A thin atmosphere might mean that the planet cannot retain heat, causing the surface to be frozen. Without an atmosphere, Proxima b would also be subject to harsh radiation from its star, making it even more difficult for life to survive. Despite the potential for liquid water, we are left wondering whether the planet's conditions could ever be hospitable to human colonists, or any life, for that matter. Some researchers suggest that water could exist at the terminator line, where conditions might be just right for liquid to remain stable. If Proxima b's atmosphere were dense enough, water might be able to exist in liquid form, creating the potential for life to take hold. But even in this scenario, the problem of radiation remains. The constant bombardment from Proxima Centauri would create a hostile environment for liquid water to survive, potentially evaporating any water that may have existed or turning it into vapor, leaving little chance for life to flourish. Of course, getting to Proxima b is another monumental challenge. Despite being our closest exoplanet neighbor, Proxima b is still over 4 light-years away. With our current spacecraft, a journey to Proxima b would take thousands of years, an impractical timeline for colonization. However, there is hope on the horizon. Concepts like the Breakthrough Starshot project are pushing the boundaries of space travel, aiming to send small, fast spacecraft to Proxima b at a fraction of the speed of light. If successful, such missions could reach Proxima b within a few decades, paving the way for more detailed studies and perhaps, one day, human exploration. Perhaps the most challenging aspect of living on Proxima b is the reality that this world is fundamentally different from Earth. The planet is cold, barren, and hostile, with no breathable atmosphere or magnetic protection from radiation. It's a place where survival would require extreme ingenuity and unprecedented technology. Colonizing Proxima b would likely mean relying on advanced bioengineering, terraforming methods, and the creation of artificial ecosystems to provide food, water, and shelter for human settlers. Even if we could overcome these challenges, creating a self-sustaining colony would require a level of cooperation, resourcefulness, and dedication on a scale humanity has never before attempted. Could we ever live on Proxima b? The question itself invites us to reflect on what it means to be human. Throughout history, we've sought to push the boundaries of exploration, reaching beyond the known to discover the unknown. Proxima b represents a dream, a vision of life beyond Earth, a testament to our desire to explore the stars. But while the dream of colonizing a distant exoplanet is alluring, the reality is far more complicated. The challenges are immense. The technology is still in its infancy, and the risks are unknown. Yet, as with all frontiers, the quest for survival will continue to inspire us, drive us forward, and shape our destiny as a spacefaring species. Proxima b remains a symbol of the future of space exploration, a distant world that holds both the promise and the challenge of humanity's expansion into the cosmos. Whether we will ever live on Proxima b is a question for the future, one that will require incredible advancements in science, technology, and human determination. As we continue our search for life beyond Earth, Proxima b will remain a beacon of possibility, an ever-present reminder of how much there is still to discover in the universe.